This is a continuation of our Unit 3, Day 3 notes on function notation. So we've done example 2, we're going to look at example 3 here. This time, notice that we're calling our function g instead of f. That's fine, this is function g. And so I know the g of x equals 6 minus 3x. I want to find the g of negative 5. What that means is that my x value, my input value, is negative 5. So I'm going to plug in what I know. The g of negative 5 equals this expression, 6 minus 3x. But they've told me that x equals negative 5. So I've just plugged in negative 5 where I used to have an x. So still the g of negative 5, which is really just a label for what this answer is going to be. The g of negative 5 is going to be 6 plus 15. So the g of negative 5 equals 21. All right, over here I want to find x when the g of x equals 48. So the whole equation this time equals 48. 48 equals 6 minus 3x. Okay, I knew the g of x equals 48, and so I plugged in 48 right here where I saw g of x. Now I'm just going to solve and find x all by itself, so I'll subtract 6 from each side. 42 equals negative 3x, and I'll divide each side by 3, and so I get negative 1, 4. Negative 14 equals x. Okay, so when g of x equals 14, I know that x had to equal negative 14. Okay, so the g of negative 14 equals 48. If I plug negative 14 back in here, I will get 42 plus 6 is 48, and that checks my work. All right. So down here, now we have an h of x. Our function is called h, that's all. So if h of x equals x squared minus 5x plus 3, we want to find the following. What's the h of 8? Again, I know what my input is. My input is 8, so I'm going to plug in 8 any place I see an x. So I have 8 squared minus 5 times 8 plus 3. I have 64 minus 40 plus 3, and I have 24 plus 3, which means I have 27. The h of 8 equals 27. If I plug in 8 into that function called h, my ending value will be 27. Right over here, I want to find the h of negative 4. So this time I have a negative number that I'm going to plug in as my x, and so I just need to use parentheses and be very careful. Okay, my original equation is h of x, which is now h of negative 4, equals x squared. I'm going to put that negative 4 in parentheses and say that's squared, minus 5 times x. My x is negative 4, so I'm putting that in parentheses, and that's plus 3. Okay, h of negative 4, this is just a label telling us what to call our output. So negative 4 squared is 16, negative 5 times negative 4 is 20, and I still say plus 3. So I have 36 plus 3 is 39. The h of negative 4, the function h, when I plug in negative 4, is going to give me positive 39 as a final value. Our next problems are word problems, so we have to work through and figure out what the words are telling us. So example 5 says the money, M, that Sam earns each week depends on the number of lawns he mows. We're going to say the number of lawns he mows is N. So money depends on number of lawns. Okay, so I need to figure out, if I know the independent variable, I know independent variable is input. I know those are my x values. And the dependent variables then will be my output values or my y values. Okay, Sam earns money. The amount of money he earns depends on the number of lawns he mows. So the amount of money is dependent, right? So I know that the amount of money is my dependent variable. That's going to be the y dependent. It's going to be the y value or the output value. My input is the number of lawns I mow. So I know that the number of lawns I mow is the input. That's the independent variable. However many lawns I mow, the amount of money I make depends on the number of lawns I mow. All right, so since I know that n, or the number of lawns I mow, is the input, I know that the output is the function of n, right? So I'm calling my function m this time. So the m of n is going to be the output, and n itself is going to be the input, all right? So the output is equal to 28 times the number of lawns I mow plus $64. Okay, that means that if I'm looking at the m of 3, if my value n is the number of lawns I mow, then when m of n, when n is 3, I know that means that I mowed 3 lawns. Mowed 3 lawns. Okay, so if I have something like the m of n equals 85, that's my output. So that means that I made my money equals 85. And so I could figure out maybe how many lawns I mowed. Okay, so if we look at example 6, we're going to think about independent and dependent variables again. We're going to think about inputs and outputs. The height of a flower H in centimeters depends on the number of months it has been growing. Okay, so the height is the dependent, right? Height is the output, and the number of months, time, is independent. All right, so time is the independent variable, and the output is what happens after I plug in some amount of time. So I'm calling this function h, and my h of t equals 11t plus 13. So if I want to find the h of 4, that means that what I'm doing is I'm growing for 4 months, right? So I'm just going to plug in 4 any place I see that time. So this means that I have 11 times 4 plus 13. So I have 44 plus 13, which is 57 centimeters. Okay, if I grow for 4 months, then I expect my plant to be 57 centimeters tall. So if I tell you that the h of t equals 63, then I know that after t months, my plant grew 63 centimeters. After t months, plant grew 63 centimeters tall. Okay, look for the next video when you're ready.